In this video, we're going to take a look at multiplication and division with radicals. Unlike radical addition and subtraction, which require the radicand to be the same in each term, radical multiplication and division do not require the radicands to be alike. For example, let's say we want to multiply 3 square root of 2 times 5 square root of 11x. We multiply 3 times 5, which gives us 15, and then square root of 2 minus 11x, which is 22x. Let's take a look at another example. Suppose I'd like to multiply two binomials, 3 minus square root of 2 times 8 plus square root of 2. Here I can use the FOIL method. First, outer, inner, and last terms. First is 3 times 8, that's 24. 3 times square root of 2, those are our outer terms. That gives us 3 square root of 2. Our inner terms, negative square root of 2 times 8, give us negative 8 square root of 2. And our last terms, negative square root of 2 times square root of 2, give us negative square root of 4. Now I'll combine like terms where I can and simplify. So I have 24, and then my like terms in the middle, 3 square root of 2 minus 8 square root of 2, give us 5 square root of 2. And then we have minus, and the square root of 4, since 4 is a perfect square, is 2. Now I'll continue to combine like terms. 24 minus 2 equals 22, minus 5 square root of 2, and we're finished. Let's take a look at an example involving division. Suppose we wish to divide square root of 28x to the 5th, y to the 3rd, by the square root of 7x. First, we will rewrite the expression so it's under one radical, 28x to the 5th, y to the 3rd, divided by 7x. Now we can divide 28 by 7, that gives us 4. X to the 5th divided by x. When we divide like bases, we subtract the exponents. So 5 minus 1 gives us 4, or x to the 4th. And then we have y cubed, all under the square root. Now I look to see if I have any perfect squares that I can take out of the radical. And I do. The square root of 4 is 2. The square root of x to the 4th is x squared. And for y cubed, because I'm taking the square root, 2 goes into the exponent 3 one time with 1 left over. So I can take out a y, and I'm left with the square root of y. In some cases of division with radicals, it will be necessary for you to do what is called rationalizing the denominator. Suppose we have the square root of 7 divided by the square root of 3. We could rewrite it under one radical, but since 3 does not divide evenly into 7, there's another route that would actually be better for us to take. So we start by leaving it in its original form, square root of 7 divided by the square root of 3. And then our goal is going to be to get the radical out of the denominator of our fraction. So in other words, we want to rewrite this expression so that there is no radical in our denominator. We can do this by multiplying our fraction by the square root of 3 divided by the square root of 3. Essentially, we're multiplying the numerator and denominator by our denominator, square root of 3. When we do this, 7 times 3 equals 21, so we get square root of 21. divided by 3 times 3 is 9, so we get square root of 9. This happens to be a perfect square. The square root of 9 is 3. So our expression is now rewritten as the square root of 21 divided by 3. That's called rationalizing the denominator. Well, that's it for this video. Hopefully you have found it helpful, and we'll see you next time.